everybody, we are going to be back for part 3 of our Lewis structures now, and we are going to be drawing Lewis structures for ions this time. So we are going to start off our Lewis structure, and we are going to be drawing the Lewis structure for the ammonium polyatomic ion. Now, ammonium is our only positive polyatomic ion. And when we start off drawing Lewis structures for ions, honestly, the work is kind of the same to start off with. So what we will do is we will find our total electron count. So if I look here, we know that nitrogen is 5 electrons in the valence shell. And hopefully you're kind of getting the hang of this. Hydrogens each bring 1, but in this case I have 4 of them. So I'm going to get a grand total of 9 electrons. When we draw Lewis structures, unless you're getting into more advanced structures in more difficult chemistry classes, you are going to be wanting to draw Lewis structures for things that have even numbers of electrons. So if you do the addition and you get an odd number, something is kind of weird there that's probably happening. So what is going to happen in this case is this plus here, as you remember, means that we have lost an electron kind of somewhere in our happenings for our particular element or ion that we're talking about. So if I have a plus charge here, what it means is that this little cluster of atoms originally did have 9, but now it has lost an electron. So what I'm going to do is I'm going to subtract 1 from the total because of the positive charge here. And now in my Lewis structure, I can only use 8 electrons. Okay, so when we're dealing with ions, you have to take into account the charge by adjusting this total of electrons here. So it's not 9 electrons, it's only 8 because I've lost an electron because NH4 is positive. So then it kind of all goes in the same process then. I have my nitrogen in the middle, and I'm going to draw 4 H's coming off of it. Okay. The next thing I need to do is I need to check how many electrons I've drawn in with my bonds and subtract them from the amount of electrons I can put in the compound. I've got 1, 2, 3, 4 bonds drawn in here, which means I have 8 electrons represented in my pictures, and that means I have no electrons left. So here is hoping that this Lewis structure works. The hydrogens are good because they have 2 electrons connecting them, and if I look at the nitrogen here, the nitrogen has 8 electrons around it because I have 2, 4, 6, 8. So my octet rule is good. When we draw an ion and you're done with your Lewis structure, to indicate that it is an ion, we need to put brackets around it, and then you put the charge there as well. And that lets us know that that whole little cluster of ions, or this whole little cluster of elements here, has a charge of +1 as it's interacting with other things. Okay? The other example, and I want you guys to try this one on your own and then we'll go over it, is NO2-. Now, this is called the nitrite polyatomic ion. We didn't ask you to memorize this one, but it is another polyatomic cluster. So what I want you to do is I want you to pause your video and then give this example a try, and then we'll go over it in just a couple seconds. Good luck. Okay. So NO2-. Nitrogen, 1, 2, 3, 4, 5 columns over in the main body of the periodic table means that it has 5 electrons that it's bringing to the party for its Lewis structure. Oxygen brings 6 valence electrons, and there are 2 of them. So I've got 12 here. And then I have 5, so this grand total is 17 electrons. And like I said, we want to have an even number of electrons in our picture. That helps in this case, or it is helped in this case by this charge here. So your ions are either going to add electrons or take them away. And in this case, because it is a negative, it means that something has gotten 1 extra electron. If this would be a -2, you'd add 2 electrons to your total. And if it's a -3, you add 3 electrons to your total. Okay, so I'm going to add 1 electron to my total, which means my picture is going to now need 18 valence electrons in its actual overall Lewis structure. So nitrogen here is going to go in the middle, and I'm going to connect it with an oxygen on each side. Every bond that I draw in, I need to take away 2 electrons from my total. So I'm going to take away 4 electrons, and that leaves me with 14 electrons to satisfy the octet for the oxygens and the nitrogens. So I'm going to start on the outside like we talked about. 1, 2, 3, 4, 5, 6 electrons need to go on the oxygen because with the 1 bond on there, it only had 2 electrons. Now it's got 8. So let's not lose track. I've got 6 electrons that I added here. This oxygen also needs 6 electrons because it only has 2. So I got 1, 2, 3, 4, 5, 6. So that means now I've got 12 electrons in my picture and I only can put in 14. So that's what I've got. Got to check the octet rule though. This O and this O are good for the octet rule. This nitrogen in the middle only has 6 electrons on it. So what does that mean? It means that we're going to have to put in a double bond somewhere. And it doesn't really matter which one you pick it from. It could be this oxygen or this oxygen. You couldn't pick this pair of electrons to do a double bond because if I move them, the nitrogen still only has 6 electrons around it. So you have to pull the electrons from something that has a full octet. So I'm just going to slide them over from the right oxygen. Again, it's not going to matter which one you pick it from. And then I'm going to redraw it. So I'm going to have nitrogen. I'm going to have a double bonded oxygen now and a single bonded oxygen. And if you want to redo the math, we have 18 electrons still that we could start with. But now I've taken away 6 of them. And that's going to leave me with 12 electrons. And now I'll redistribute these for the octets. So this oxygen on the left-hand side here only has 2 electrons currently drawn around it, so it still needs 6 like before. Okay, so that's 6. This oxygen here has a double bond, which means that it has 4 electrons around it already. I'm going to add 4 more to satisfy the octet rule. Okay, so that's 6 and 4 is 10, and I've got 2 electrons left, so here is hoping that the nitrogen needs 2. It had 6 drawn around it, and it's got 2 dots, and so we're good with our octet, okay? We aren't done yet. We need brackets around it, and then we're going to draw a negative sign to indicate that that's an ion, okay? So there's lots of practice for you. There, I believe, are 8 practice problems for you to give a try, and then we'll see how they go. If you have questions, show up in a meet, and we'll get things cleared up. Good luck.